the in the data mining, basically what we have now understood the data, right? The data collection, the data analysis in a brief, the structure of the data and how we use the data basically in data in our business. So the data mining is just another tool for getting the information out of the data, right? So for an example, let's say if there is a fertilization clinic, and have you heard of in vitro fertilization? Yes, sir. Yeah. So in vitro fertilization basically take the embryos and take the sperms, and then they try to fertilize the eggs and into the machines, right? So they normally now the thing is they can fertilize a lot of embryos, right? So which one will the problem is in this case basically is how will they choose, because not all of them die, not all of them survive at the end. So they want to maximize their resources. They have only limited amount of machines in their capacity, right? So they want to maximize the outcome, how many they are fertilizing, how many they are hatching the fertilizing, and how many of them will actually turn into babies, how many of them will survive. So the problem is how will they choose which one will survive, which one will not survive. So basically what they are looking at is they have collected some historical data about the almost about 60 features of the embryos. Said they are noting the outcomes, they are noting the weight, they are noting the color, maybe they are noting the other features of the embryos, and then they look at the last previous records, what are the outcomes of these 60 features and which one of them survive. So they are looking at the patterns, what are the conditions, what are the combinations of survived ones, and what are the combinations of which are not survived, right? And then based on that they run the model, they run the program and make the permutation combinations. So if you see there are a lot of combinations here, right? The 60 features is a lot. So if you say how many combinations are possible for these 60 features, there how many how many different type of patterns can be there. You understand patterns, right? And you understand permutation combination or not? Yeah. So how you calculate the how many combinations can be there for 60 features? If there are 60, how will you calculate? Can anybody calculate? How would you calculate? If let's say there are two variables, how many combinations possibly can be there? So wait, sorry, there's like 60 features for each embryo, then there's 60 embryos? Yeah, no, there are each embryo, there are 60 features. So now the features combination can be different, right? So let's say it's A, B, C, D. Let's say there are 60 different features. How many combinations of these features can become? So there can be, let's say only two are only there are two possibilities, right? So 0 and 1. So how many features, how many numbers can become with these 60 features? 60 and 120? No, it's normally 2 to the power of the features. To the power of features. Yeah, so means 2 power of 60. So how many combinations can be there? Mathematically you can calculate that 2, and then there is the square of on the top of 6. There is a symbol in your Excel. You can use that and put 60. So you will know how many features can it be. So the way to calculate this is, let's say if there are only two features, so the way is 2 to the power of 2. So how much is that? 4, right? 4 combinations. And if there are 3, then 2 to the power of 3, there will be 8 combinations. So that's the way you calculate how many combinations are possible. Now, for humans, for a normal computer, for a normal spreadsheet, looking at 2 to the power of 60 combinations is not possible, right? It will take long time. By the time you are able to understand which embryo will be able to survive, the embryos are dead already, because you don't have enough time. So for that, the data mining power is used, where they are looking at the historical records, looking at the features of those who are not survived, and then they are predicting the models. If there are these combinations of features, then the embryos will survive. If there are these combinations of the features, then embryo will not survive. So how they are noting? So means they are noting down every single feature every single day. How does it turn out, right? And they are putting into the system. So there is a huge data they are collecting in order to run the predictive models. So the data mining basically is doing is it's a feature. The definition will come later. Basically, it's try to identify the patterns in the data in order to predict and prescribe the future actions. In our analytics, in the previous analytics, we were saying we will have four type of analytics, right? So what was those four type of analytics? One was decision, another was descriptive, prescriptive, and predictive, right? So in the decision analytics, you don't normally have to use a lot of data mining, but the description. So when you want to describe the relationship between something, how they are featured, what are the delays, what is the customer profile. When you want to predict something, what will happen in the future, you are practically using the data mining techniques to predict, to prescribe based on the previous outcomes, based on the certain assumptions that you tell your system to be able to calculate. So the standards. So that is the data mining. Now the another example that was given is basically the cow. So let's say you are in a farm and the farmer has a selection. The cows are described by another 700 features. Now the problem that the farmers usually have is which cow is getting old and now is need to be killed, right? So how you will define that? So you need to look at their age, you need to look at their the production, you need to look at their health, you need to look at their features, when you should do it. Because if you do it too late, it may not be, you will not get the good price of all the remains, right? Or if you do it too early, you may be losing your productivity. So then again, it's a classic example of how data mining will help. So what they will do is they will look at the previous records and the farmer's decision based on their experience, right? So farmers may have done some wrong decisions, some may be right decisions, right? Based on their experience, they also learn. So what they are doing is they are recording it, they are taking the decisions, they are telling the system based on these features, we make this particular decision so that the system can learn. So that is the machine learning part here again. So you are telling the system during the features, what type of features, what kind of decisions are made. So that system understand the patterns and they develop their own models, they develop their own algorithm. The difference between artificial intelligence and machine learning is this. In artificial intelligence, you are telling the system what is right and what is wrong, right? What kind of decision you need to take, the system need to take. In the machine learning, thus you are not required to tell, you are just telling the actual situations. The machine, it's the computers are learning by itself, they are developing the algorithm by themselves, understanding the pattern of the data. How they do it, I have no idea. How they are developing. So basically the computer scientists are developing the neural sciences, neural networks similar to our brains. Our brain also have neural networks. Our brains create new neural networks all the time and destroy the previous neural networks whatever is not used. So whenever you are learning any new thing, there are new connections which in our brain are created. So similar way that, huh? Machine learning, the ideal situation for the example, we don't need to for the ideal situation like for this cow. When we consider their productivity. Yeah, no, you don't have to do that. You have to just provide them the historical records and the actuals. The machine learning, they will create their own algorithm to understand what has been the pattern. and what could and when based on your decisions which you have already taken, the machine will automatically develop their own algorithm to take the decisions in future. So for example, let's say there is a Robocop, and then now based on the actual decisions the policeman is taking in order in catching the thief or analyzing the detection, right? You go to a crime scene and you are trying to look at, oh, these are the features, these are the cues, these are the clues which you are taking from different things. You feed that into the system, and then when you have enough data, maybe let's say thousands of cases or 10,000s of cases, the system will be able to predict what will be happening, and then you don't need to tell them what is the meaning of this clue, because the system already is smart enough to understand that by himself. And then they can look at the similar situations, so you don't have to tell them exactly what. So they will be able to understand the difference between an orange and an apple by themselves, by looking at the shape, by looking at the color, by looking at the but you just have to tell them that something looks like this is apple, something looks like this is orange. That's it. The rest they will judge by themselves. Medicine probability, no, I don't know. Put the data, I mean, they will symptoms or maybe diagnostic. They can come out with the diagnostic. There are already. So these the blood samples you are doing, there are machines who are doing the analysis of these blood samples, and the reports are coming out of the system. So they will be able to tell you what are the diagnosis, what are the problems in your blood, what are the possible disease that you are carrying. The scientist, the person who is doing the actual work is just verifying that only. They are not actually doing it anymore. They are not people sitting behind a microscope and calculating this no more. It's all machines who are doing it nowadays. So there will be a time when they will look at the face, and they will be able to look at the blood pressure. They will be able to look at the blood count. They will be if you give them the blood sample, the robot, whoever is sitting on the doctor's seat, will be able to say you have a cancer, you don't have a cancer, or you have a diabetes, or you have a this, or you have this problem. So that is possible. But that is will take time, and you can imagine now in these examples how much data you have to feed into the computers, right? You have to be very careful in giving them the enough intelligence that you are prescribing basically all the features, so they have to understand everything. So it's not possible to key in the data, right? So that's why there are new techniques where they are recording the feature. So they are making the video records of everything. They are then the system is analyzing that video record and taking the information from there. So you don't have to actually key in the information. Otherwise, if you key in the wrong information, it will be wrong. It will create wrong algorithm and wrong decisions as well. And that has happened in the past. So it depends on how accurate the data you are providing, the machine will learn in that sense. If you are providing wrong data, the machine will learn also wrong. So that is the power of the data mining, which is supporting both the artificial intelligence and machine learning. Okay. So now the data to information, what kind of data we are creating, right? The society is creating a lot of data every time. The data is coming from the business, from the science, from the medicine, from the economics, from the geography, from the environment, from the sports. Uh, for example, there may be, if let's say you are noting down the history records every single day, how in Myanmar case, if let's say you have been recording in the past, there have been 3 coups already. So people were already able to think, oh, there may be a possibility of another coup. Why they do it? Because they have seen the circumstances are pretty much the same. So if you let's say if you feed all this information into the system, and say, okay, these are the conditions, these are the economic conditions which are happening, these are the political situations which are happening. uh, the military is moving into certain way, or the government is moving into certain ways, then the systems may somehow will be able to predict when is the next coup gonna happen, or based on the conditions when the next thing is gonna happen. Peoples have already modeled the share markets, right? And they are able to predict when is the next economic crisis is going to come, based on the models, based on the things. So the scientists, the investing analysts, they are already predicting that the another economic crisis is just on the door, so it's not very far away, based on the history of the other crises that they have seen in the past. And how they are doing is they are looking at the stock market, and they are trying to understand what is the conditions of stock market before those crises and now. So they are trying to understand when this next economic crisis is going to come, and as per them, it's not very far, or maybe we are already in that process. So that's the so you have to, so we are creating a lot of data all the time, right? So if we are able to put that data into the practice, into the systems, the systems will be able to understand and predict what is going to be what is coming, right? The systems are able to now predict the life cycle of the peoples, based on the lifestyle they live, based on the meals they eat, based on the work they do, because they have enough data already. Any specific software like we saw this SAP, ERP? So SAP and ERP are very dumb systems, to be very honest. They are not. They are not. They are not the data mining, the artificially intelligent tools. Those systems are not there. But you may be using these systems like Netflix or YouTube. They are powered by data mining, they are powered by artificial intelligence, they are powered by machine learning. And what do you think, what kind of things they are doing with this? Can you think of any example? Monitor and they change our ad preferences, so they monetize out of it. Ad preferences is one, so they are monitoring what you are doing and what kind of ads you would like. So they are predicting what kind of ads you would like, and they are showing those ads to you, and they are making money out of it. Any other example? I think the Facebook does the same thing. Yeah, that's ad example. But I'm trying to get another word for it, which is there. What does Netflix do? Netflix don't show ads. It recommends what movies we like. Yeah. So how they do it? How they know what movies you would like? Because they know our history of what we watch. History and the pattern that we like. So what variables do you think they might be using? Maybe. Huh? That I don't know. Sorry. Regional. Maybe they like monitor the tape. If we maybe they are monitoring the many variables among yours. So what kind of actor you like? Maybe is there any pattern in the actor or actress you watch the movies from? They will look at the genre, right? Are you watching mostly comedy movies, or you are watching mostly horror movies? You are mostly watching science fiction? You are watching mostly what are you watching? They will also look at how many movies you actually finish. So maybe let's say if you start a movie, you watch it for 10 minutes and then you leave it. So what signal it gives them? It tells them that you don't like this movie, right? So then they will note down what is the genre of that movie that you did not like, what is the actor, what is the actress, who are the directors, what is the storyline, and then they will note all these features in their system, and then they will see if the next movie which is coming in, will you like it or not. They, based on your pattern, based on your watch history, did you watch similar movies completely? Did they have the similar actors which you have been watching in the past? Did they have the same genre? Did they have the similar storyline? What would you like? So that is the or maybe your search history, right? So you may be searching the movies, but you are not actually watching them. But the search history also gives them the idea what you are looking for. And then based on all these parameters, I'm just guessing, maybe they are looking at much more. Based on those parameters, they will recommend you the movies. And do you think those recommendations will always be similar, or will they change in the future if you change your history? They'll change. They will change, right? The moment you change your search pattern, the moment you they will continue to monitor and update your personal preferences. So you can imagine, if let's say Netflix has maybe how many, a million users maybe, then they are keeping a track of individual preference of those 1 million users. 1 million are very less. I know they have much more, hundreds of millions of users, right? So they are monitoring the preference of every single person every single day, every single moment you are spending on them. So you can imagine their data source, right? We are scared by looking at 10,000 rows in Excel, and now you are talking about millions of rows of data, right? YouTube. How many hours you spend on YouTube on a day? On an average, by the study, average people spend about 3 hours on a day in a day on YouTube, and there are more than a billion users on every day on YouTube, right? So now if Facebook again is similar statistics. Say Facebook has a billion active user on any single day on an average, plus they spend 3 to 4 hours on Facebook on every single day. So now you can imagine how many data of how many rows of data they are keeping, or how much data they are actually updating on a day by day, on a daily basis. So that gives them so much power to understand you. If you want to download your own Google profile, you can download. I think there is a search. Google has your personal data, and then it will give you your own personal data, what you have been watching, what you have been visiting, what you have been doing. They will give you everything. If you want to delete it, you can delete that, so that Google does not know anything about you. And now the Apple, did you heard anybody heard that Apple is coming up with a new policy that they will allow the apps to collect data only based on your agreement. So the apps now have to ask for a very specific permission from the user to collect their data for marketing purposes. If you say no, they will not be able to collect your data, and it means they will not be able to give you the personalized recommendations, personalized data, personalized ads, or personalized marketing messages. So, do you think it will be good or bad? Good for us. Why good for you? You will not be able to get your favorite movie or favorite products. I think maybe once it's launched, like a few days later, the people will missing some part of that. Not the Facebook also, they have changed the policy. Yeah. Cannot, yeah, collect the information. Like, yeah. For me, I don't spend much on that, but say I prefer the privacy. Yeah, so there are views where the people are some advocates are saying it's good because it will give you the necessary information based on your own things, but it's not good because they are collecting your personalized data, and it's actually changing your behavior. So there are studies where they are saying that the social data, the social networks, they are actually changing your behavior, changing yourself. So they will show you the movies which you like, but slowly they will change your behaviors as well. So that's a bit scary thing, but let's not go into that. So the data, so we come back to our class, data mining. The society, as we were saying, produce huge amount of data. This data is potentially a valuable resource for anyone, for the marketers, for the companies to understand their customers, for yourself to able to discover your own patterns and your own habits. But the raw data itself, which we are generating every day, is not useful unless we are able to identify the patterns, and we are able to use those patterns to either predict or prescribe something, like Netflix is doing, like YouTube is doing, like Facebook is doing, or there are many other companies which are doing those things. So they are here. We are concerned with the machine learning techniques for automatically finding the pattern. So we create algorithms so that whenever the data pass through those algorithms, we are able to update and understand the patterns of those data and predict what is going to happen in the future. So that's the machine learning. Now this can be represented as a structural description or a black box model. So this is the structural definition. So if then rule, structural definition descriptions means if then. So if something happens, what is there, right? So if this happens, then it will happen. So on the screen you will see an example where very small set of information is there based on the age. So it's a recommendation whether you should get a glass or you should not get a glass, right? So based on the age of the peoples, they categorize if young age is myopic eye. There is a ageism in the eyes, means the eyes are getting damaged because of the age. There is a tear production rate is reduced or not. So will you recommend a lens? What kind of lenses are you going to recommend? So if this is happening, then no lens is recommended. If young and hypermetrop and no and the tear production rate is normal, then you are getting soft lenses. If this is the age of the guy and the rest is normal, then you are not getting any lens or you are getting a hard lens. So basically what you are doing is you are telling the systems what happens. Then the system will be able to identify a pattern. So in this case the pattern is, if the tear production rate is reduced, then the recommendation is none, because in both the cases when you are not able to recommend a lens, in the both the cases tear production rate is reduced. So one variable is tear production rate. Then what else is there? What else? When are you else are saying none? Means the young age, right? The whether you are astigmatic or not. So if astigmatic is not and young and you are young, you are not getting the recommendation anyways as well. But if not young, if young and astigmatic, then you are not getting the one as well. But when are you getting soft? You are getting soft when you are young and hyper metro. So these are the example of identifying the patterns. So the systems are generated to understand the patterns between the data. This is the result, right? This is the so what we are saying in our examples, in our first example, when we are saying in vitro and the cow culling example, what they would do is they would put all the features, 660 features or 700 features. We will identify all the features and then we will tell them the decision. Okay, this is our decision, right? Whether to kill or whether not, whether it survive, whether it's not. And then the system will look at all the features and see, is there any pattern, is there any specific thing that is happening in a specific decision, and then it will be able to come up with if then rules. So these are called structural descriptions. The non-structured description, if you are not able to come back with if then rules, then it will become a black box which you have to analyze in details. So this is the one way of identifying the pattern. Is it clear? Not clear. Huh? So the black box basically, if it's not, if the system is not able to identify the if then rule, so there's not structure, there's no clear rules, then it's a black box. But if there are clear structural definitions, the if then rules, then it's a structural description. Yes, if you are able to see the pattern, then it becomes a structural definition. So the idea is to identify the patterns, right? So that's the basic idea. Now the meaning of the data mining, the objective is the data mining. So the meaning of data mining is it's a computational process, means it's done by computers of discovering the patterns. So the idea of data mining is to understand the patterns in large data set with an objective. So there are large data sets. So there are like maybe thousands of rows of data or millions of rows of data, and with an objective. So you have an objective in your mind. So data mining does not happen if you do not have an objective. You cannot just go and do a data mining, right? When you are going for fishing, you need to have an objective, right? That you want to catch maybe 10 fishes or you want to catch a fish. You are not just saying, okay, I go to the river and maybe if there are fish, I will catch them. Not like this, right? So you are trying to do data mining with an objective in your mind. So you want to understand the patterns, and data mining helps only with the patterns. So you have an objective in your mind that you want to understand some patterns. And then you are doing some computational process, means via computer. That is called the data mining. So it's to extract the data from a data set and transform it into understandable structure. And then aside from the raw analysis, it also involves database management aspects. It also involves data pre-processing. We will learn that a bit in a bit of more details. Model and inference consideration, intersection metrics. These are all technical details. Include the visualization and the online updating into your dashboards and everything. So that is all a part of data mining. So that is the data mining at the intersection of many disciplines. So data mining involves a lot of things. So it includes mathematical modeling, it includes statistics, regression analysis, permutation combinations, and time series analysis. It involves pattern recognition, it involves machine learning, it involves knowledge of database, it involves management science and information system, and it involves artificial intelligence. So that is the all when all these are intersected, that's the data mining. So this is looks something like a Venn diagram, right? So if you see the data mining in terms of how where it does sit in our organizations. So the basic model is your data source, where it's papers, files, information provider, database system, or your transaction processing system, your ERP and your other things, right? So that normally is managed by the database administrators. Above that, you see data warehouse and data marts. So there are OLAP, analytical procedures, and the management of database. So that these two jobs are done by database administration. But here you don't have all the decisions. You cannot make decisions, right? Because this is just a data. You have no idea, you have no understanding of it. But then we do the data exploration, which is called the statistical analysis, querying and reporting the data, and then we do the data mining to find the information from this particular data. So that is the job of the data analyst. So these two are the job of data analyst. And then this data is given to the business analyst, who is going to present the data and use the visualization techniques, maybe by charts, by pie charts, or by the diagrams that we saw last week. And then it will submit to the end user. Who is the end user? The management. And those are going to make the decisions. So the higher information is available, they have a potential to support the business decision. So business decisions cannot be made on the data source itself, right? Because there is no analyticals, there's no analytics happening there. When it's go to the data mart, also it's not helpful because there is no analysis yet of the data. After this, the data exploration and data mining helps. So there you have much more potential to support the business decisions, and the highest potential is in the data presentation. So when you are able to present the data into a simple format or into a summary or a synthesized way, then you are able to make the decisions. So that's the highest potential. So this is the structure of the data mining in between the business from the data warehouse that we have learned and the business decisions. So we have actually learned the data visualization and presentation and make how we make decisions. We learned yesterday about the data warehouse and data sources. Now we are looking at the information discovery part. Clear, right? Hello? Yeah.